Hey everybody, this is our second to last section in Chapter 7 and it's all about graphing polynomials. The one hard thing about this section is that there's a lot of variations, so just do your best you can to ask as many questions as you need and really spend time focusing on these examples because I'm going to try to hit as many of the types of problems you're going to see as I can. So I just want to review really quickly the degrees and the number of zeros. We've talked about this a lot in multiple sections. So if you have a degree of 1, the number of zeros you could have are 1. If a degree of 2, then there's 2 zeros. 3, that means there's 3 zeros. And 4, that means there's 4 zeros. So remember, degree matches the number of zeros. The new part of this, what we're going to start talking about, is how we can use this to graph. So I want to add to this that we can have turns in our graph, okay, so a number of curves, and this is calculated by looking at our degree. So if you notice, our degree here was 1. Well, the max number of turns you're going to have would be 0. So this means it's going to be a straight line. Okay, if the degree is 2, you're going to have a max number of 1 curve. Okay, so that might look like a U shape. And I'll draw these next to it. So a line like that. With 1 curve, it might look something like this. If it's a degree of 3, it has a max of 2 curves, so it could look something like, here's a curve and there's another curve. So 1 and 2. And then if it's a degree of 4, you could have a potential of up to 3 curves. So that might look something like this. 1, 2, and then 3. Like that. Or facing different directions. It just depends on the problem. So and I put this little star down at the bottom, if you have exactly 4 real zeros, so maybe you get that the zeros are 4, 7, -1, and 2, those are all real numbers, then that means you're going to have 3 curves. But if you maybe have some imaginary ones in there, then you might have less than the max number. It just depends on the problem. So just be aware that these are max numbers, not necessarily set in stone. Alright, so now we're going to talk about what's called end behavior. End behavior is extremely important in terms of graphing. So end behavior is basically which direction the graph goes as x approaches positive infinity, so as you go farther and farther to the right of the graph, and as you go to negative infinity, so farther and farther to the left. And there are basically 4 different cases that we're going to be working with, and you're going to want to be able to refer to this quite often, so make sure you put it in a handy spot. And it's all calculated by the degree and the leading coefficient. So you got to know what those two things are. So the first one is if our degree is odd, so maybe 5 or 3 or 1, and our leading coefficient is a positive number, then when we are looking at our function, our end behavior is going to be going a certain direction. And the same thing applies if the degree is odd and even and so forth. So if it's odd and positive, our graph is going to be going up as it goes to the right. I'll do this in a different color. So as it goes to the right, it's going to be going up, and it goes to the left, it's going to end up going down. Right now, what's in the middle is going to change because maybe you have 3 curves in here, or maybe you have 5 curves in here. But what's going to happen at the end will always be the same. So when it's odd and positive, it's going to go all the way up to the right and all the way down to the left. If it's odd and negative, it just flips. So the degrees are both odd. Now we just have opposite signs. So this time, going to the left, it's going to go up all the way, and going to the right, it's going to go down. Okay. If we're dealing with a degree that's even, so maybe something squared or something to the 4th, and it's positive, then both of our end behaviors are going to be going up when it goes negative, and then also going up when it goes positive. All right, so both are going to be going up, even and positive, always pointing up. And then when its degree is even and negative, they're both going to be pointing down. So maybe there's a bunch of curves in here, and then it points down again. Okay. So this is the 4 main cases, and you're going to want to be using these anytime we're asked to graph functions, because you're going to want to know which way the graph should be pointing when you go to the right and when you go to the left. So now let's just look at this example here. This is just a simple polynomial. It says determine the end behavior of the following polynomial. We have negative x to the 4th plus 4x cubed minus x squared plus 6. So our degree is going to be 4, and our leading coefficient is -1. So we need to look at our information. Well, our degree is even, and our leading coefficient is negative. So in this case, this is going to be our last case on the chart the bottom right. And so we would just need to know that as, and this is how you would want to write it, as y, oops, sorry, we'll do this backwards. As your x values approach positive infinity, so in other words, as your graph goes to the right, which way does it go? Well, y, so f of x, approaches negative infinity. That means it goes down, all right? So this is just the formal way of writing it, and you'll probably see this on later math if you go into pre-calc or calculus. Okay? And then if our x's go to negative infinity, so in other words, if we're going to the left, so as x goes to negative infinity, then our y value also goes down. So in other words, this is the fancy way of saying that when we have an even but negative problem, both our arrows point down. Okay, but I want you to get used to writing it this way. So as x goes to positive numbers, y goes down. As x goes to negative numbers, y goes down as well. All right? If you have any questions about that notation, let me know. Hopefully that was pretty easy. Now we're going to get into the actual graphing. So this is where you're going to have to pay attention. If you want some graph paper, feel free to ask. Here we've got a really basic function that you have to graph, and I put the 3 main steps in order to graph. The first one is to plot the zeros if possible. So when it's factored like this, you automatically have the zeros, and this is a huge help. If you can factor it but it's not factored already, you also want to try to do that. But sometimes you can't factor, and we'll talk about what we do with that in a minute. So in this case, it's factored, so we want to look at our zeros, where all zeros are all these that are in parentheses with the x. So I would have that x minus 1 equals 0, and I would get x equals 1. So x equals 1 is a 0. I do the same thing for this, and I get x equals 2 as a 0. And then the third one, I get x equals 3 as a 0. So what I'm going to do is I'm going to plot those points on my graph. So we have, and I give myself a little bit of space here just in case. So I'm going to have the point at x equals 1, the point at x equals 2, and the point at x equals 3. All right, so those are our first 3 points of our graph. Then I want to figure out my end behavior. Well, now we need to look at our degree and our leading coefficient. Well, this isn't factored. There's nothing squared or anything like that. But what you should notice is that there's 3 x's. There's 1, 2, and 3. So what this means is that our degree is 3, and our leading coefficient is the number out in front, which is the 5. So our leading coefficient is 5. So what you should notice that this is an odd function and it's positive. So go back to your table. Okay. Well, when it's odd and positive, the right goes up and the left goes down. So we know, whoops, that on this graph, I'm going to go from my farthest 0, that this is going to be going up from this point. Okay. As I go to the right, it's going to go up. And then as I go from the left, it's going to be going down. Okay, now this may not be exact, okay, but it's an estimate. And then from here you're going to start connecting points. Well, we know this has to have some curves to it. Well, in a degree of 3, so our degree equals 3, how many turns could you have? Well, we always said in the very beginning, if there's a degree of 3, it could have a max of 2 curves. So we're going to go back to our graph. It would have a max of 2 curves. So what we're going to do is connect this. So we're going to go up to the next point and then go down and connect back up to get our second curve. So what you do is kind of connecting points and making the curves so that you have the 2 max here. If you don't like doing it that way and you want more precise, which is always a good thing, you could always make a table of values and plug in points that are between your zeros. So you could plug in a point like 1.5. 2.5 and 3.5, and you could get those ordered pairs and then plot them. And you could also pick something to the left of your 0 and the right of your 0. So maybe like plugging in 0 and +4. And this would be a really good way to get a very accurate graph, and I would highly suggest you do this. All right? So this is your basic function. This is, like I said, it's not going to be perfect graphs, but they're going to be estimates. As long as you've got your zeros, your end behavior, and maybe a few points plotted in between, that's all you need. So now let's take a look at this one. This one is not fully factored, but we're going to go ahead and try to factor this one out so that we can plot the zeros all the way. So if you look at this equation, the x minus 4 is already factored. Unfortunately, we can't factor this 2x squared minus 2x plus 1. It's already factored as low as it can go. So we're just going to go ahead and set this to be our first zero. So we're going to plot the zeros. So we know that x is going to be equal to 4. So I'm going to plot 4 over here. So let's see. So there's our first. And then we need to figure out in step 2 what our end behavior is. So we need to look at our degree and our leading coefficient. Well, we have 3 x's here, so if I FOIL this, my highest exponent is going to be an x cubed. So our degree is 3, and then our leading coefficient is going to be a positive 2. So in this case, we're odd, and we are to our positive. So if we go back to our rules, when it's odd and positive, same thing again. We're going up to the right and down to the left. So we go back to our graph. So we know we're going to be going up to our right, and we know we're going to be going down to the left, but the problem here is that we have some information in between. We have to be able to have some curves. Okay, there's no other points to connect, so before we can do the rest of our end behavior, we're going to go ahead and plot some points. So this will be our step 3. So plot points. Unlike the last example where I had 2 endpoints, so I could go from the left I went down and from the far right point I went up, this one I can't share the same point. So I need to figure out what goes on over here and then go ahead and graph it. And this is going to be where what you get may vary from person to person. Your curves are going to be a little bit different. You just have to pick points to plot. So I'm going to go ahead and pick something like positive 2, 0, negative 2, and so forth to try to graph. And you may need more points to get an idea of where your curves are going to be. So when I do this, and maybe I even pick 2, 1, and then maybe negative 1 as well, just to get an idea. So when I plug in 2 into my equation, I get 2 minus 4, and then I get times 2 times 2 squared minus 2 times 2 plus 1. And now I can simplify. 2 minus 4 is negative 2. 2 squared is 4 times 2 is 8 minus 4 plus 1. Okay, so I'm just simplifying. 8 minus 4 is 4 plus 1 is 5. So negative 2 times 5 is negative 10. So when I plug in 2, I get negative 10. Okay, so that's going to be way down here. So maybe I'll count by 2's. So 2, 4, 6, 8, 10. And I plot that point. Okay, if I plug in positive 1 into the equation, and of course you might need more space, we get 1 minus 4, and then 2 times 1 squared minus 2 times 1 plus 1. So this gets me negative 3, and then 2 minus 2 plus 1. That gets a 0, so we end up getting negative 3. So when I plug in 1, I get negative 3. So 1, negative 3. So right there we can kind of tell that we're going to get a little bit of a curve. And so maybe it might help to plot positive 3 as well. All right, so you want to start getting the shape of the graph by plotting as many points as you can. And really it requires you to plug in numbers. So now let's do 0. If I plug in 0, 0 minus 4, 2 times 0 squared minus 2 times 0 plus 1. We get negative 4. Those zeros go away, so I get negative 4 when I plug in 0. So 0, 1, let's see, and actually I just realized I didn't count by 2's, so that goes here, and 2, 3, 4, so that goes back down. So notice that this is starting to go back down, and this will actually get me my curve because I have I have something going down, then back up, and then we know it has to go back down. So this is going to get me my final graph. So I'm going to go down to this point, back up, around, and down. So because it was a degree of 3, I have my 2 curves, one here and one here. And we know that to the left it pointed down. So these may not be perfect. You may have picked different points, and that's okay as long as you have the right curves in the right places, and then you have your end behavior and your zeros. The more practice you get, the better you get at it. Now sometimes you won't be able to find your zeros at all because you won't be able to factor, you won't be able to use synthetic division without it working, and so really the only 2 steps if you can't factor at all is to determine the end behavior and then make a table of values. So in this case we've got x to the 5th, which we know is a degree, so that's our degree is 5, and our leading coefficient is positive 1. So just like the last one, it's going to go up to the right and down to the left, and you can kind of draw that to yourself before you start plotting. And then I would just start making a table of values. So it doesn't really matter what you pick, but when you don't have anything to go off of, you're going to want to try to pick as many points as you can, maybe going from like -2 all the way to +2, just to get an idea of where your graph is. You might even have to go more than that, maybe some in between with some fractions, and then plot your points. So I'm going to go ahead and do this real quick. You should do the same by pausing the video and filling in the table, and then we'll check our graph here in a second. Alright, so I went ahead and filled in my table from -2 to +2, and notice that I got -32, -4, -4, -2, and 32. So you can see that even picking a small number like -2 and 2 gets me a really big number. So this shows that it shoots up really fast and shoots down really fast. So what I'm going to do is I'm going to pick a few more points in between the points we've already plotted in hopes to get an idea of where this graph could go, where it's going to curve, where it's not going to curve, and so forth. So I'm going to go ahead and pick a few more ordered pairs that are in between. So maybe I pick -1.5 to go between -1 and 2. I pick a +1/2 and then +1.5. And this could at least get me started. And like I said, you could pick different points. When I plug in -1.5, I end up getting -9. So I could go to -1.5 and then all the way down to -9. So that's 4, 5, 6, 7, 8, 9. So that's right about there. When I plug in 1/2, I'm going to get I think it was -3.7 roughly. So I go to +1/2 and then -3.7, 1, 2, 3.7. And when I plug in 1.5, so let's see, 1.5 to the 5th is 7.6, and then 1.5 squared is 2.25. So I can add that together to get 9.85 and then -4, so we get 5.85. So 5.85 roughly. So 1.5 goes up to a positive 1, 2, 3, 4, 5, almost 6. And maybe I pick one more. Maybe I pick -1/2. I didn't really pick that one. Oops, -1/2. So let's see. -1/2 to the 5th is going to get me -0.03. So -0.03, and then 0.5 squared is -1/2 squared is going to give me +0.25. So let's see, 0.03, and then subtract 4, so we get -3.78 or -3.8. So -1/2, -3.8. So right about there. And now I have enough points that I can get an idea of what my curve looks like. So notice it's going down on the left, which is what we want. Then we come up, hit that point, and it has to come back around, then curve up through this point, and then all the way up. And obviously you want to have that somewhat of a straight line. So there would be my graph. All right. So table is always the way to go, but the more points you have, the more accurate it's going to be. Now the last thing that I want to talk about today is our turning points, and these are important. There's basically two turning points we're going to talk about, local max and local min. And anytime I talk about max and min, I'm referring to a y value of an ordered pair. So the local max is the y value of a point that's higher than all the nearby points, all right? And then the local min is the lowest points of all the nearby points. So for example, if I just have a really simple graph like this, and I'm graphing like that. Okay, so my local maxes might be this point, this y value right here. Maybe it's a, maybe this is, let's see, -2, +3. My local max would be at y equals 3, and then this is also a local max because it's a high point. So I would calculate that y value, and then my local min will be my lowest point right here at the curve, local min, and you would just figure out what that y value is. All right. So I'm going to go ahead and have you guys graph this function. It says identify the x-intercepts, the local max, and the local min. So I'm going to just go to something like Desmos or your graphing calculator if you have one. It's up to you. And we're going to type in this equation just very quickly to see what it would look like. If it says graph on your own, no calculator, then I would like you to make a table and so forth to go ahead. But if it doesn't, then you can always use Desmos or some kind of graphing calculator to plot. So we've got the equation 0.5 x to the cubed, if we would let this load. Alright, so we've got our 0.5 x cubed plus x squared minus x plus 2. So here's what our equation looks like. Notice our m behavior, we could always figure it out. So it says find the x-intercepts, or the zeros. So in this case, where does it hit the x-axis? Right here. And now Desmos is nice because it tells you the point right away. If you have a graphing calculator of your own and you want to use it, and you're not sure how to get those exact points, let me know and I can show you how to do that. So you would say that your x-intercepts, and I'll go over here, intercept was at x equals negative 3.7, whatever that ordered pair was. And then if you want to find your local max, go to the highest point here at the top, and you would write the y value. So our local max was when y was equal to, what was it? Oops. 4.134. So y equals 4.134. And then, of course, our local min, it would be the lowest point in our curve, and that would be 1.792. So our local min would be when y equals 1.792, or whatever that ordered pair was. Yep, 792. Okay, so that's as simple as it is. You've got to graph it, find the x-intercepts, the local max and min, and then you'd be done. And like I said, if it says to use a graphing calculator, you are free to. If not, I'm expecting you to graph it by hand using a table of values and your end behavior, or your synthetic division to find exact zeros if you can, and then going from there. So if you have any questions about graphing, please make sure to let me know. Just remember, the more points you have, the better your graph will be and the easier it will be to answer the questions. Thanks for listening.